Hello, I'm Andrei, CTO of Copter Express, and today we will tell you about educational application of PX4 platform. I will tell you about our company and the power of drones in education.
I'm Aleksey Shlykov, I'm CEO of Copter Express, and I'll tell you about our community, our competitions, and our students' projects.
Hello, I'm Oleg. I'm the lead developer in Copter Express, and I'm going to tell you more about the technical approach we have chosen for our software framework.
Before we begin our presentation, we would like to make a small spoiler. We now will start a conference call with Kazan, Russia, where on competition which is called Russian Robotics Olympiad, our drone kits are used by children to compete with each other. So please see what's going on. It's live stream.
Something goes wrong.
So, can we call again?
We have a Wi-Fi. Yes, everything. One more time.
Okay. Okay, so few words about this competition. It's a robotics competition for school students and students from all over Russia. Now are in Kazan, and they compete for who can program autonomous flight with drone better. And our platform use PX4, and it's so PX4 is leading platform in these competitions. And I hope we will show you how it works in real life. Okay, then we begin our presentation, and maybe we will call again
later. Yes.
Okay. Okay. So our company was founded in 2013 in Moscow, Russia. We are called Copter Express because our primary goal was to start commercial delivery of goods with drones. So in 2014, the first pilot project was started, the delivery of pizza in Russian city of Syktyvkar. This project was a great success as an advertising campaign. It was first regular commercial delivery with drones, and media all over the world told about us and about this delivery of pizzas with drone in northern Russian city. This project lasted for about a month, and it was successful as advertising campaign, but not so from economical and legal sides, because the delivery were quite expensive, and Russian laws wasn't ready for such a use of UAVs. Then we started to think, how can we make delivery better and cheaper? And we realized that piloted delivery, and this was piloted, is not the way to go. And we started to work on autonomous flights and autonomous delivery. And in 2016, in Samara, we started our first autonomous delivery project using the drone on Pixhawk autopilot with APM firmware and Raspberry Pi single board computer. We programmed it to fly from point to point and then recognize Aruka tag, its marker like QR code, and then land precisely on this market. So we are working on autonomous delivery nowadays too, but also now we work on some other projects with autonomous drones, like our autonomous monitoring solutions. We decided to add the automatic charging station to our drone system, so drone can be programmed to perform flights by some time of schedule and without any attendance. So this system can work fully autonomously for quite a long time. But of course, there are some problems with autonomous drones, reliability concerns, and now we are on a pilot project stage of this development. We just completed first successful pilot project when this station was used without our attendance for several weeks in an oil production site in Russia. So that's our short story of our company as industrial drone builder. But in 2015, in Russia, the interest in robotics have risen, and we set our eyes on educational market. That time in Russia, both state and private educational institutions were eager to introduce some course on robotics as part of their curriculum. So we started to develop the educational drone kit and started to think, how can we use drones in education? There are several approaches to drones in education. First, and the most obvious, is to use a ready-to-fly drone, some kind of small drone, to teach students how to pilot drone, how to program it. But it's, in the same time, the least interesting and powerful way of using drones, because we can't teach how to engineer the drone, and students can't realize how drone really works. Some time ago, special educational products like modular drones were offered. A modular drone is a drone which meant specifically for education and consists of several parts, like one part is ESC plus motor plus prop, and then students can assemble this drone and pilot it. So they can get a bit more information about how drone works, but they still can't go to the shop, buy real parts and assemble a real large drone and found some kind of very cool startup with drone. So the most powerful but the most complicated way of using drones for education is to provide the drone as kit of common parts, which can be assembled by students, and so they will have to realize how drones really work, and then they have to configure it to pilot or program it. So we decided to go with the last approach as the most powerful and providing the most opportunities for us to use drones in education. But we wanted to teach not only how to fly using remote control. We wanted to teach how to program the drones so they could fly autonomously. And so we are entering the field of robotics and robotics education. And robotics is not the easiest thing to teach, because it's a very young field and it advances very quickly. So it's very interesting because of that. But at the same time, the educational materials are somewhat lacking. For example, if you compare documentation of ROS with docs for some kind of modern, popular, stylish JavaScript framework, JavaScript docs are like almost digested information which you could consume really entertaining, and ROS documents are just like raw food and you really need to want it to eat. So we thought, how can we provide something that will be powerful and that will be close to real adult robotics, but at the same time that will be user-friendly, so we could teach like 12-year-old students how to use it. So we had three alternatives. We could just not to use complicated tools and make some kind of simple platform so students could understand it. Or we could create some kind of wrapper which would hide the complexity of the complicated tools, so children could use it. Or the third way is to create documentation so awesome, so brilliant that even school children could understand how all of this works. We decided to go with some mix of the second and the third approaches. So we developed our educational drone kit. Our educational drone kit is a kit to assemble a programmable quadcopter like this. So we called it Clever Kit. And not only because you can make these drones really clever, but also because clever in Russian is the word for clover. Yeah, it's pronounced clever. And four-leaf clover is not only the symbol of happiness and luck, but also it resembles the quadcopter. So we called it Clever. And we ship it at kit or fully unassembled, just parts. So teachers can educate children how to build quadcopter, how to configure it, how to fly using remote control, and then how to program autonomous flight. Talking about hardware, we needed to build the drone so it wouldn't be too expensive, but it should be very tough, because students like crashing the drones like crazy very much. So we built a frame which is partly carbon and very tough, and the protection parts are all of acrylic glass, which can be very, very cheaply cut on the laser cutter, so we can provide them for almost no price. Talking about software, we had two primary goals. On the one hand, we needed to provide some kind of simple API so students could quickly start to program these drones. And on the other hand, we needed to provide some kind of navigational systems for indoor flights, because when you use drone outdoor, you of course could use GPS, but of course the majority of lectures and lessons are indoor in schools, so we needed to create some kind of indoor navigational system. And the third but crucial part of our kit is our documentation. And please, previous slide. The interesting question for this conference is why we chose PX4 as our autopilot and PX4 flight stack. To create educational drone, you need your autopilot to be flexible, because you need to use it in different educational institutions, to be feature full, to have some features like low-level control or indoor navigation support, which we need for education. But in the same time, it should be simple, because students should learn how it works. It also should be stable and mature, so students doesn't face any problems regarding our platform itself and not their knowledge. And the autopilot should have large community, because the community can help us and students with any problems and develop this firmware further. So we evaluated all the available firmwares when we created our platform, and in fact PX4 is the third platform which we used. We used CC3D with Arduino some years ago, and then for a very brief moment we used APM flight stack, but moved quickly to PX4 and quite happy with it. So the third and very, very important part of our educational product is our documentation. We wrote a large volume of documentation which covers all the topics that students need to know to assemble the drone, to configure it, to upload firmware, to set it up, to fly using remote control, to communicate with Raspberry Pi, to make scripts to fly autonomously. And this documentation is available at our website. Our main version of documentation is in Russian, because almost all of our students are Russian speaking, and many of them even don't know English well enough to read it, because they're like 12 years old. We translated this documentation to English, so you can check it out.
Yes, and now I want to tell you more about our community that we create in 4 years. First of all, I want to show you this map. Each place mark is one of center of STEM education or school or college in Russia where you can learn something using our educational drone kit. From Kaliningrad to Sakhalin, across Russia. It's very exciting. And we made it in 4 years. And what looks path for the student right now? We will tell about it with Andrei from two sides. The first about science and education, and the second part about competitions and different contests and benefits that they can have with our educational drone kit. But first of all, we make some work and we're ready to call. We will call to Russian Robotics Olympiad. It's right now, and thank you, Ramon. He helped us. And yes. Oh, yes, it's work. Finally.
Oh. Hello, everybody. My name is Sveta, and today we are located in Innopolis, at the Innopolis University in Kazan, Russia. We are provide flying robotics challenge. The main task of this challenge is to develop drone and perform full autonomous flight. We have 10 teams. We have 10 teams from 10 regions in Russia. This is students from 8 to 11 grade, and most of them use our educational drone kit with our image for Raspberry Pi. So I wish good luck to our...
Oh. Thank you, Sveta. Yes.
Bye.
Yes? Thank you. Yes. And now about path of student in Russia. Let's start from school.
Yeah, let's discuss what we can teach using drones in schools. The most obvious thing that students can learn is how to assemble and fly the drone. And usually that's where the school education with drone ends. But in fact, we can use drones to teach a whole set of different common subjects. Like, for example, physics. Topics like aerodynamics or electricity can be covered using drone kits, and it's interesting for students. But physics is not the only subject which we can teach with drones, because we also have design and engineering classes. And children are really excited to make some part for drone instead of making some boring, unnecessary parts. And when they should make something to complete a task, for example, when drone must grip an object and then drop it somewhere in the room, and they must make the tool to grip, it's much more interesting for them, and they do this with great interest. But the most interesting application, as we think of drones in school education, is computer science classes, because common computer science lessons are usually not too interesting for students, and if student is not really a computer fan, they are not very useful. But everything changes when you propose to code a drone, because almost all the students are really excited to program the drones, and they I think like, what? I can write some code as this drone will execute my commands, it will navigate through the room, it will grip and drop objects, it will fight another drones. It's really, really very exciting for students, so it's the most interesting for us application of educational drones. And now when the interest for programming is very high, we believe that schools should use drones for computer science education more and more.
Yes. And what benefits they can learn when they're using drones? First of all, they can join in university with full scholarship if they win in different contests in Russia. For example, this video from different competitions, one of them to deliver something fully autonomous way, and students from 30 to 15 years take part in it. And the winner can join university without exams. And it's really interesting for students because they can make their first step in flying robots. And it's not so hard, and it's very simple, and they have a lot of benefits. But then they can join college, for example, and make drones like a profession.
Yeah, colleges are more about working professions. So we participated in creation of new Russian state educational standard, which we called Unmanned Aerial Systems Operating. Using our educational solutions, colleges teach how to operate the drone, how to fix, maintain, troubleshoot it. And it's both interesting for college students and interesting then for their employers.
Yes, and the competition take a big part in students' life because if they win in this competition, they can find the best job. In Russia, it's a very powerful tool, World Skills Movement. It's championship of working profession. It's an international championship. And in Russia, the best students who win in this competition can find the best job because this competition interesting for companies and for students. It can connect them each other. And it's more about working profession, more about drone operating. For example, on this competition, you should troubleshooting your drone, you should flying in FPV, and flying fully autonomous. You can show your knowledge of drone from different sides. And it's really interesting for students to try to make it. But this only if you want to be an operator of drone. But science is more interesting, and you can use drone in it, in university.
Yeah, our work with universities is in early stage now, but we really believe that drones should be used more in universities because you can use them both for education and for scientific research. Talking about education, drones can be used with great success to teach estimation and control theory, computer vision, some machine learning aspects, and a lot of different topics. And if we talk about research, then researchers usually spend a lot of their time and effort to assemble the drone, to learn how to operate it before they can start really scientific work. So we believe that there is a need for some kind of platform which can be used for scientific research in universities. And we are now promoting our kits in Russia and are collecting the feedback from academic community so we could offer the best platform for research.
And what about interesting competition for students and tutors? I think most of all know a conference ROS. It's a big robotics conference each year, and this year we will organize a competition at this conference, and I hope to see someone of you. It will 6 November in Macau. It's about collaborative drone delivery, of course fully autonomous, and I hope we can show the power of PX4 at this competition and to use it. But you know, the main point why there is so many students in Russia love to use drone for programming, it's our community. You can join community in each step, in school, in college, in university, and it's interesting all the time. And when you came to our community, there is a lot of people who want to help you. Because, you know, when we start, we answered each question for ourselves. But right now, people want to help each other. Because it's, people like to share their knowledge. And we just need to give them a platform for discussion. And for example, in one of our chats, there is Ramon. Yes. Yes, and I believe that we can communicate a lot and show the best projects from Russia and to cooperate with drone code. Yes, and our team is core of this community. We start with 7 employees in 4 years ago, and now we grow to 70. We create an educational materials. We develop our framework. We organize competition, helps to students and tutors. And it's very inspiring when you meet someone who uses your educational drone kit in every city in Russia. And for us, it's very important that teachers not only learn to assemble drone and learn to fly, because it's very important that they use drone as a tool to learn physics, computer science, and others. And that's why we educate teachers. It's a very important part of our concept. For example, last year, we educate more than 100 teachers from 26 cities from Russia. And but it's not only in Russia, because this year, at the beginning of May, there was a very interesting experiment. We go to China and learn Chinese teachers from college with our conception of using drones in education. It was very cool and very interesting for us because it was our first step to join international community of educational drones. And drones interesting not only in education. It's useful for our business too.
Yeah, as Alexey told you, our small startup grew from 7 to 70 employees in several years, and that's because of success of our educational product. Our sales grew, so now we sell more than 1,000 of these kits per year. And but we are not the only manufacturer of educational kits in Russia. In fact, there is a lot of more of them. And the question is, what could help us to step aside and to dominate the market? When we created our kit, we discussed a lot internally about should we open source all of our software, because of course many businessmen are afraid that if they share their code, someone will come in and stole their hard work, yeah, and will offer the product which is more or less the same but for less price because they doesn't have to develop it. But we decided that we couldn't create a great educational product without creating a community around it. And we couldn't create a community without going fully open source. So we decided to license under MIT all of our software and to open all of our educational materials. That allowed us to very quickly expand our vision on the educational platform and to collect a lot of very smart and brilliant people around us. So from one side, yes, there is some manufacturers who copy our product, but they can't achieve any success in the market because they don't have any community to help teachers, to educate teachers, to help students, and also they don't have our expertise in field of copters and drones, so their hardware is inferior as well. And to confirm what I said, I want to show you the market share of our company and another manufacturers of educational drone kits in the Russian market. So we now are more than half of Russian educational market, and all of our competitors use closed source model. So they publish only some kind of API. And we went fully open source, and it enabled us to dominate this market in Russia. So we would recommend you to open source as much as you can if you are working in similar field, because the advantages of such approach are far, far more important than the risks that you can have.
So I'm going to tell you a little bit about our software framework. The goals of our software framework were actually to lower the barrier of entry to the world of flying robotics, especially to the world of open source flight controllers like PX4. When we're talking about the software that runs on the companion computer, there are two main approaches how you can do it. The first approach is to create some library-based solution like DroneKit or PyMavLink or something like this. It has some advantages because it's very easy to the users. They just import some Python module in their code. It's very easy. But another approach is to do inter-process communication approach like ROS and MavROS. It has a lot of advantages. At first, there are great introspection and debugging tools like RQT in ROS and ROS topic and etc. Also, you can do some very nice visualization like RVs. There's a lot of logging solutions like ROSBAG. So we think that the most appropriate variant for us is to use ROS and MavROS. The second topic for us is the positioning system, because it's very difficult to program drone to do something senseful without the positioning system. So, of course, outdoor you can use GPS, and PX4 works really nice with GPS. But we don't want to make our students go outside every time they want to test their code. So, in a lab, of course, you can use something like motion capture system. It can give you very good precision. But for educational purposes, it's too expensive. It costs a lot. So the most appropriate solution for us is to use the onboard camera-based navigation. We have a Raspberry Pi and a camera. So we developed two solutions to navigate indoors. The first is recognizing fiducial markers. So we can compute the position of our drone relative to the marker or to a group of markers. We call them markers map. And then we can use this information to navigate. The second solution is optical flow. We just use the standard OpenCV's phase correlation method, and then we can compute the shift between two frames that camera sees. Then we can transform this shift to the angle, and then we pass this information to the flight controller. So this works really well on Raspberry Pi, so our drone can just hover. Of course, it may be a little drifting, but it's hovering. The next topic is flying it off board, because of course you can use automation to fly autonomously, but for indoor flights it's very limited. The only thing it can do, it just flies through points, so it's limited. It's not fits some fun tasks. So flying off board is not so easy for our students. For example, if you try to write some sketch for raw MavROS to just take off, then it would look like this. So our students should understand a lot of difficult concepts of ROS, like publishers, subscribers, callbacks. It's too difficult for novice programmers. So we actually decided to create a simple wrapper around it, and we called it Simple Offboard. So Simple Offboard is just a ROS node. It wraps some MavROS stuff, and this is the project template for our students. So Simple Offboard is just 8 services, and they allow the user to make different tasks and control the drones at different levels, on the level of position, rates, velocity. So, for example, the program that takes off looks just like this. It's just one line of code. So our students write one line of code, and the drone will take off and hover using optical flow. So as you see, navigate function has the target point coordinates. It has frame ID. The frame ID is actually a coordinate frame for the target points. It's just a regular ROS frame, like you know in MavROS is base link, which is attached to the drone, or map, which is attached to the origin of a local coordinate system. But we also added another frame that we called body. Body is just like a base-link frame, but it's not tilted by roll and pitch, so it's very easy to control the drone in terms of fly forward, right, left, and something like this. Also, thanks to ROS toolchain, this can be performed just in one bash line. So we just call the same navigate service and pass the same parameters to it, and the drone will take off, so you can even program your drone using bash scripts. Then, for example, if you want your drone to fly left, then you just set Y coordinates to 2, for example, and Y-axis is points to the left, so the drone will fly left. Then when you want your drone to fly on its initial position, then you set Y to -2, and the drone will return. Then, when you want to, for example, land, we created a very simple thing. You just call land service, and don't care about anything. You just switch the drone to auto land mode, and the drone will land. So this is some example of a program you can do. Here you see the drone flies square, and you see how easy is the program. You just called navigate 4 times. You just sleep until the drone reaches the target position. So it's really easy and fun for our students. Also, when you enable Aruka recognition system on our platform, each Aruka marker will create its own coordinate frame. So if the drone sees the marker, you can actually navigate to the target point relative to the marker which it sees. So like in this example, we set frame ID to Aruka _107, and the drone sees the marker and navigates and hover above it. Moreover, with the same line of code, you can even make your drone to fly towards the moving marker, like in this video. So this is just one line of code. So this is using optical flow system, but optical flow system has some feature. The drone may drift away because optical flow only computes the velocity, but there is a system that is called vision position estimation. Then you can use a map of markers. Then you input this map to our configuration file, and then our system will calculate the position of the drone relative to this map, and you can fly relative to the map of the markers. This would create an Aruka map frame. So, like in this example, drone flies to the left edge of the marker map, then it flies to the middle of the marker map, and then it lands. Now, the next simple example that we can use to teach something our students is this program makes the drone flies a circle. This program is very interesting for education purposes because with this, our students can understand the application of sine function, cosine functions, and geometry functions. So they can program the drone to do something interesting using this math function. Also, when you want to get the state of your drone, you don't need to subscribe to the topics. You just call get telemetry service. This service gets frame ID as an input and give you everything about your drone you need as an answer. So the frame ID is the coordinate frame for X, Y, and Z coordinates. Also, it has attitude, rates of the drone. So, for example, if the drone sees a marker, then you can set frame ID to Aruka underline the ID of this marker, and you know the coordinates of the drone relative to the marker if it sees the marker. So it's very useful. So this is the example how it looks in Python. You just call the function and get all the telemetry. Because subscribers is maybe too difficult to analyze. Then it's a lower level control on our platform. You also can set the desired velocity, set the desired attitude, and set rates. This is useful for some aggressive maneuvers. For example, this is the code that performs a flip with the drones. As you see, it's very easy. You just bump up for a little time. then you set a rotating rate for your drone, then you wait until the conditions are met, and then you just return your drone to the position control mode. And this is how looks the execution of this program. So the drone takes off, then it performs a flip, then it's returned to its initial position and lands. Now, we don't want to distribute our platform for our students as just packages or ROS packages, because installing ROS packages and building ROS packages is not so easy. So we decided to create an image for Raspberry Pi, so our students can just get this image and write it to SD card. But we don't build this Raspberry Pi image manually. Instead, we have a continuous integration system that uses QEMU emulator to emulate Raspberry Pi. Then we install everything you need, mount a Raspbian image, configure network. So every out drone is a Wi-Fi access point, install ROS Kinetic, and some additional software. For example, we have this web interface. When you get the links to all the web tools that are available on our platform, for example, you can view the documentation, you can view some interesting visualization. Also, many of our users use Windows, so we have web terminal. So you even using Windows, you can program your drone just using web browser, and it will be a real programmer. It's not like it's real command line. So you learn really cool stuff. This is nice package that is called Web Video Server, so you can view all the image topics that you have. For example, you can view the image from your camera, and we actually built this image to each commit on our project, and we run tests. So if something fails, we know about it. And how you see there, all the stuff I tell you about is just hosted on GitHub. It's CopterExpress/Clever. So you can follow it, you can check it out, you can run it, and please start it if you like. So this was a brief summary about our software platform. And now Aleksey will tell you about actual projects that was created using this platform. Thank you.
Yes, and I want to tell you about 3 most interesting projects that can show our platform from 3 points of view. The first one is Drone Show. It's very popular in Russia school camps because you can make it very fast with our simple framework. And it's very exciting first step in robotics because you create something interesting. For example, this video made this week on Monday. It's a show from school camp where 5 full autonomous drone makes flip. Flip? One more time, flip. Okay, yes, and yeah, it's look very exciting for them because they understand why navigation indoor is so hard and how to create a control server to control all of these drones. The second project is about warehouse inspection. Team of students they find a problem that it takes a lot of time to scan all barcodes, and they want to try to make it with drone. They take our educational drone kit and our framework and make this project. And the most interesting part that these students only 13 years old, and they can create it by themselves. It's fantastic because 3 years ago, it was a problem even for us. The third project, it's very interesting because it shows how important to work with students and interns. 2 students came to us in our internship program. And at first they assemble drone, then they start to learn to fly. But it was catastrophic. They crash every time. They fly 2 seconds and then repair drone for an hour. But then they think, we're not so good at piloting, but we are great engineers. Maybe it's not only way to learn to fly. We can create a sphere protection around our drone. Then they make this first prototype. It works. And then they make the second version. They use carbon tubes in the second version. It was very interesting. Andrei, second version. Thank you. Yes, and it works, and they fly a lot of times. They crash in the walls, they crash with big high, and drone is okay. Then they write an article, and it became very popular in Russia. We was very inspired by it, and make a product. Yes, you can see it. Oleg already turned it on. It's a drone for delivery something indoor. And we use it a lot from action, you can see. For example, we usually deliver sweets with this drone because we upgrade it and make a cover of textile cover around our drone. And it's very hard to touch props, and it's almost fully safety to fly through the people. And we more than 20 PR events using this drone, and it was very exciting. For example, it's delivery of water to speaker. We also deliver a clicker and a lot of other things. And the main point in this project is that how student project became a product of our company. And because for us it's very important to take the most smart students, came to our internship program and create some projects. And now we create even, it's a funny competition like drone wars. You take 2 drones like this and you should crash. And someone who can fly, he's win. And it's very exciting to people who see it from the side, but it's not good for engineers because they should repair drone every time. Now our platform is very good for projects. And every year we make a big event in Russia. It's Copter Hack. Do you remember that we educate teachers? And then, once a year, we call all teachers, all students that use our educational platform in Moscow. And, for example, last year there was 200 of participants, and they make some interesting projects on our hackathon. They have only 24 hours, our educational drone kit, and then can make all they want. To add some sensors, to add some different nodes as they want. And for us, it's very inspiring to meet people and hear their story, how they use our drone, what projects, how they educate students, and how they use our project. And at the end, I want to tell you so how we taught 1,000 students how to program drones. There is 3 main points. The first one is that we make an easy framework, a really simple framework. And first step to flying robotics is very simple. You need only 1 day to assemble drone, learn, make your first fly, and make your first autonomous flight. And it's very important that we use PX4 and ROS because our platform is very simple, but it has a big potential to go deeper. You can start from our platform and then understand how PX4 works, what ROS is at, and many other things. The second one, because students have benefits. It's very important because for students it's interesting with a practical way. They can, for example, join university with a scholarship, just make interesting project with drone. And the third point, that we create a big community in Russia. And when you start to program drone, it's very important to talk to another people who making something interesting with drones too, because it's very inspiring when you talk with someone online and then see this person offline, in competitions, in contests, at hackathons, and other different events. You know, like us here. We take these three parts: simple framework, benefits, and our community. Take them together and taught 1,000 students to program drones.
Yeah, but we've made all this way from Moscow not only to share our story, but to promote the usage of educational drones in schools, in colleges, at all the stages of the education. Because the drone is the wonderful tool which can educate and inspire students at the same time. And I believe now we need more than ever a lot of inspired and talented engineers and developers. So go to schools, to colleges, and inspire people with drones, because it's a really absolutely motivating thing. And I believe that in a few years, when we will meet again at some summit, many participants will say, you know, I started to work with drones at school, and I love them. Thank you.
Thank you. I'm sorry. Can you please make this for our colleagues from Russia? One moment. Yes.
Wait, please.
Thank you.
Are there any questions from the audience?
Please.
Please raise your hands. You want to go first?
So usually how long is your hackathon? Like one day, 24 hours?
It's usually from 24 to 48 hours. So it's the whole day with the night work, you know, or it's even 2 days.
So if we were to do another Dev Summit in the future, should there be a hackathon? Would you like?
Maybe some kind of developers workshop, you know.
Yes, maybe we can do it together. Maybe we can. Maybe we wait a year for our hackathon. Maybe this year. Let's make it together.
Yeah,
with drone code.
Hackathon attracts a lot of interest, and a lot of people were into the world of drones because of hackathon. Actually, me, for example.
So ask the audience here to raise your hand if you are interested in that portion to add that to a Dev Summit.
Oh, great.
Oh, we're waiting each of you.
We want very much
hackathon.
to make international hackathon next time, so it would be really great.
Who's next?
Just a two-part quick question. So how much do the drone kits cost, and what are your plans for expansion internationally?
Our drone kits cost about $700. And yes, we are planning to expand, and we are slowly expanding into Chinese market and into
Chile market, to United Arab Emirates market. For example, there was an interesting project where students from Aachen, Netherlands, take our drone and take a part in some competition. I forget the name, but it was very interesting for us.
All right, so 2 questions. First, what's the flight time?
Oh, it's from 8 minutes to 12 or 15 minutes. It depends how many of payload on the drone.
All right, quite long. And which version of Raspberry Pi was used?
Model 3B+.
So that's quite some computing power. Thank you.
Have you looked into maybe integrating with Microsoft MakeCode or any kind of Blockly language to make this relevant to even younger users?
You mean Scratch
yes.
or something, yeah?
Yes, we have a Scratch.
This platform is very extensible, so our students created a Scratch edition to it. We are thinking about adding this to the main platform. Maybe we add, but now it can be installed, but it's not so easy, but it can be added because of extensible nature of ROS platform and interpersonal communication platform.
So I saw that you have a lot of schools in Russia that are using it. How do the schools finance the kits? Is it financed by the government, or is it single schools?
It depends. Mostly, it's the school can buy it with government money, and they buy all that they have with government money, and they buy our educational drone kit to learn some subjects, for example, and to take part in competition because schools are interested in competition in Russia. How many they have money is depends of results in competition of students too.
Thank you.
There's a hand.
And for those $700, do you get, or what do you get? Is the drone and?
Yes, you get the drone and all the parts of drone. And for example, if you STEM educational center, you have free educational courses for teachers. Then all our help desk, our material, our files to laser cut, you can just cut it in your lab. And you don't need to buy them one more time.
But you get the drone unassembled.
Yes, you get drone unassembled, and you have and not only drone, and tools too to assemble it. You just take this box, go, I don't know, in park, assemble drone, and then fly.
Can you help me? How many people do you have supporting your communities on the forums? How many employees do you have to put into that job?
I think it's over 15 people in our company. It's people who worked in our educational part of company. They organized competitions, contests, they organized courses, and they create educational materials. But community helps themselves, because when we start, we help to every person, but now they help each other. And though we have not so many people to create this community, now it's really big because people want to help each other and want to share their knowledge.
And also, it's not a forum, it's just a chat. So you can enter this chat. It's a public chat, and everyone can answer.
Yes, but it's in Russian, It's not in English.
No, there were some questions in English, and
yes.
We can answer in English.
Yes.
Any other questions? All right, I have two questions, actually. I see that you were trying DroneKit and then MapRops and ROS. Have you tried the Map SDK?
Actually, when we started to design this system, there was no Map SDK. It was about 2017. So no, we haven't tried. We now look to it and we think about it. But now it's Mavros.
Right. My second question is, what can this community do to help you and support you in training people?
Could you repeat, please?
What can this community do for you to help keep supporting you in providing
what can
training
this community
services?
do for us?
Yes. You got the main developers here.
Of course, we can see pull requests. A lot of Russian students send, not a lot, but some Russian students send us pull requests, of course. It's not only the code, it's about the documentation as well. And also what...
the question is about this community. So
yes.
You can merge all of our PRs immediately.
Also, if you star our repository, it would be just great for us because we do everything for the stars. On GitHub.
Of course, it's a joke, but we are really communicating with some of core developers, and we are very grateful for their support and for their aidance in how should we fix some problems.
Also, we want the core developers to understand more about what we do, so they understand more our PRs to PX4. They know what we do, so it's easier to them.
And you can help us maybe to provide an education with drones in your countries, in your cities, in your universities, because it's very interesting for us. You can contact us, maybe write to us. We can help you to start it in your country, your city, because we believe that education with drones is future, and it can inspire students a lot.
All right. Thank you, guys.
Thank you.